Hi there. During our exam revision, we came across this question shown here. And remember, I said to you, this is a very long question. And I said that the suitable place this question will probably appear will be in paper B, because it is very long if you think you're going to do it by hand. Okay, so we're going to do this question here in Excel. So let's read the question. Now, the question says the delta of this derivative at time 0, so this is where I'm reading, is 7%, and the gamma is 10%. The bank which issued the derivative wishes to delta hedge its position in the most efficient manner. Assume that the share price can also be modeled in continuous time with a geometric Brownian motion. Okay, so they are telling us that so that we can be able to use our Black-Scholes pricing formula. Okay, so, and they give us a volatility of 0.1 consistent with a Black-Scholes framework. Now, they say determine the delta hedging portfolio as a combination of risk-free assets, the underlying share, and a European call option on a share with a term of 3 months and an exercise price of 100. Now, if you remember during our revision, we derived these three equations shown here. And we said we are looking for C, Y, and X. Y and X and X here. Okay, I want to explain how we got these equations because I do explain it nicely and in a very easy way how to come up with these equations. Okay, so the exercise of this video here is to show you how to calculate the value of C, which is your unit in the risk-free asset, the value of Y, your unit the unit for shares, and the unit for the call option. I won't explain how to derive these equations. I did explain in my revision video. So my aim, the reason why I'm doing this video is to solve for C, Y, and X using Excel. So now, remember, in order to solve these equations, we needed the price of the call option. So I'm going to go now and calculate that. Now here, I am given the Black-Scholes calculator. So that means I can calculate the price of this call option here. Okay, let me zoom this here. Not too much. Okay, so remember the share price we discussed when we were doing this question. It was given, so it was given to be 100. So I'm going to put in 100. The strike price, the examiner just told me that the strike price of the call option is 100. So I'm going to come here and put 100. The maturity time, this now they are saying with term of 3 months. Okay, so your maturity, you're going to put 3. You can put 3 here. Remember, I did explain this to you. You can put here 3 for 3 months as long as your risk-free rate will also be in months. And my risk-free rate is 10%, if I'm not mistaken. Okay, so my risk-free rate is 10%. My volatility, okay, my risk-free rate was given in the question. Let me make sure if I'm punching the correct risk-free rate. Sorry, the risk-free rate is 5%. So that is what I'm going to substitute here. So I'm going to put 5 here, and you are given the volatility. The examiner told me that assume that the share price can also be modeled in continuous time with a geometric Brownian motion with volatility of 0.1. Because this calculator is working in percentage, you can't go now and put 0.1 because it will be wrong. That will be something else. But 0.1 is 10%. Okay. So I'm going to put here 10%. And you can see down here, the value of the call option is 16. I need that. So I'm going to come here and say a value of a call option and tell my examiner that the value of the call option is 16. Now, if you look at my equations, you will see that I need the value of the call option. I need the share price there. Remember, the initial share price is 100. So I'm going to have my share price to be equal to 100. And you see that I need the delta of the call option. Remember the delta of the call option. So I am going to need the delta of the call option. Now remember the delta of the call option. I warned you during my exam revision that you must go in the exam knowing this expression off by heart. It is phi of D1. Okay, so it is this value here. It is phi of D1, so it is this value here. So the delta of the call option, I'm just going to pick up this value here. Okay, let me see, let me go in my equations and see what I also need. I also see that I need the gamma of the call option. Okay. So I also need the gamma of the call option. Now, remember I discussed this with you. I told you that the gamma of the call option is the standard normal distribution, the standard 0,1 normal distribution evaluated at D1. But how am I going to do that in Excel? Okay, I'm going to press equal to here. Then I'm going to press norm. Okay, and you will see here norm.s.dist. Okay, you're going to press that. Actually, I think I'm wrong. You're going to press norm. Okay, so you go, oh, sorry, you're going to press this one here. They say returns the normal distribution for a specified mean and variance. So remember, I said to you, the gamma of the call option is the standard is the standard normal 0,1 with mean 1 and standard deviation with the mean, so, oh gosh, with mean 0 and variance 1. So it is a normal distribution with mean 0 and variance 1 evaluated at D1 divided by S times sigma times the square root of t minus little t. Okay, so in actual fact, I think I'm wrong here. I'm going to remove this here and I'm going to say this my standard normal. Okay, my standard normal evaluated at D1. So I'm going to evaluate a standard normal evaluated at D1. Now this will be equal to the norm distribution. Now this is a normal distribution. You can see it returns a normal distribution for a specified mean and standard deviation. So I want a normal distribution evaluated at D1. Okay, so I'm going to punch this here. The value of X I want to evaluate this normal distribution is D1. So I'm going to pick up that. My mean is 0 and my standard deviation is 1 because this is a standard normal 0, 1. And here you see when I move to cumulative, I am given options here. So they are telling me to put true if I want the cumulative distribution function. They are telling me to put false if I want the probability mass function. Now I want the probability mass function, remember phi of D1. So I'm going to put here false, okay? And I'm going to close my bracket, which means now I'm ready to calculate the gamma of the call option, because now the gamma of the call option will just be this here, okay? So let me put my bracket. The order of operation will be this here, divided by the share price, which is 100, times my volatility, which is 0.1, times the square root of my maturity time minus my initial time, that is 3 months. I'm going to take the square root of that and I'm going to close that bracket. And I see my gamma then. Now, to agree with me that now I'm ready, oh gosh, I'm ready to calculate this value of X here, because X will be the gamma of this derivative here, I'm hedging, divided by the gamma of the call option. So my X will be, so the X value will be the gamma of this derivative, okay? And the gamma of this derivative, the examiner told me it is 10%, which is 0.1. So I'm going to have 0.1 divide by the gamma of the call option, which is this here. And I'm going to press equal to, okay? So I found that the value of X. Now I need to go and find the value of, now I've got X now, okay? And if I look at equation 2, I can find Y, okay? I can find Y, to agree, because now Y will be the delta of the derivative minus X times the delta of the call option. So now I'm ready to calculate my Y value. That will be equal to the delta of this derivative, which the examiner told me is 7%. I'm going to have 0.07 there, minus X multiplied by the delta of the call option, which is this value here. So I'm going to pick up that value there. I'm going to close that bracket. I'm going to press enter. And I am going to get negative 5.6. Okay. Now, I'm ready to find the C value here. Because if you look at your equation 1 here, you can see that the value of the derivative is equal to C plus Y multiplied by the share price plus X multiplied by the call option value. Okay, so in actual fact, my C will be equal to what? will be equal to D, the value of this derivative which we derived during the exam revision. It is 2.4972 minus Y times ST minus X times CT. Okay, that will be your C. So if you do the calculation there, your C will be the value of this derivative which we calculated during the exam revision. It is 2.4972. 2.4972 minus Y times the share price. So I'm going to pick up the value of Y multiplied by the share price, 100, and I'm going to add then the value of X multiplied by the value of the call option. So I'm going to have my X, which is this here, multiplied by the value of the call option, which is this here. Okay, that will be the value of C. Okay, now it's time to punch this in my calculator, and you can see my answer written nicely. Okay, so let me put this in brackets. Seems like I made a mistake there. Why am I adding that? Because I'm supposed to subtract this, because plus go to the side. I am very sorry. This is supposed to be a minus. Okay, and I'm going to get the 453.14. So I'm going to hold 453.14 in risk-free asset, and because I've got a negative value for the value of Y, which is the underlying share, I'm going to sell 5.600 of underlying asset, and I'm going to hold, okay, sorry, I am going to hold 6.83 for 5. Okay, European call options. Okay, so there is my delta hedging portfolio. Okay, it was great being with you. I hope you enjoyed this. I wish you all the best with your exam revision. Bye-bye.